Hello students, welcome to The My Dream, India's first ever e-learning education platform, where each and every topic is taught with what, why and how concept. So today we are going to start with a new topic called refraction under the chapter light. So let us first understand what exactly the refraction is. Refraction is basically defined as it is the phenomenon of change in the path of light in going from one medium to other. So basically, when there is a change in the path of the light in going from one medium to other, then the refraction occurs. Okay? In reflection, we discussed about the concept of same medium. The reflection occurs in the same medium. But here, in case of refraction, we are talking about the different mediums. Okay? So, the refraction is basically defined as the phenomenon of change in the path of light in going from one medium to another medium. So, the concept of medium, the concept of different medium is basically being emphasized where in the concept of refraction. In case of reflection, basically the reflection was happening in the same medium, so we were not giving any emphasis or importance to the concept of medium over there. In case of reflection, why? Because the reflection happens in the same medium. But in case of refraction, it is the phenomenon of change in path of light. Why there is a change in path of light? Because it is actually traveling or going from one medium to other or to another medium. Okay? Now, why are we studying the concept of refraction then? Basically, there are n number of applications which are associated by this concept called refraction, such as twinkling of stars, rainbow formation in the sky. Okay? Now, how this refraction phenomena happens? Basically, the answer to this question of how we are going to study with the help of cases. Let's discuss the first case over here. The first case is when light rays travel from rarer medium to denser medium, it bends towards the normal. Let us look at this diagram over here. I have written air and glass. So these two are two different mediums. Air and glass, these two are totally different medium, right? Now, out of these two, we know that glass is a denser medium, air is a rarer medium. Fine? Now you can see the dotted line over here. This dotted line represents what? Normal. This is what? This ray is incident ray. And this ray is what? Now this ray will be refracted ray. And this is what? Angle of incidence. And this is angle of refraction. Fine? Now, what is the case first? The case first is when light rays travel from, this is a light ray which is traveling from where? From rarer medium. Here air acts as a rarer medium. So when light travels from rarer medium to denser medium, 2 means to denser medium. So here glass is a denser medium. It bends towards the normal. You can see that this is the incident ray. When it comes in contact with the glass, inside this what happens? It gets refracted inside the glass. Why? Because the glass is what? Glass is a denser medium. So this refracted ray is bending towards the normal. You can see it is towards the normal. This dotted line is what? It's normal. Okay. And this refracted ray you can see is towards the normal. Fine. And this angle we know is angle of incidence. And this angle is angle of refraction, because refraction phenomena is happening over here. Now, an important concept over here is what? In case 1, that as it is the refracted ray is bending towards the normal, so you can see that I have written over here the angle of incidence is greater than angle of refraction in this situation. Because here you can see the ray is bending, the refracted ray basically is bending towards the normal. So this angle will be smaller and this angle will be larger. So angle of incidence is greater than angle of refraction. Now the question is basically that why you can see that why it is bending. The question is basically that why the refracted ray is bending towards the normal. Why is this the case? Because the speed of light, I mentioned this in previous video, that the speed of light changes when the light ray travels from one medium to another medium. So the speed of light, it gets decreased where? In denser medium. And here denser medium is what? Glass. So once it enters inside the glass, the light ray enters inside the glass, the speed of light ray gets decreased. That's why this refracted ray is bending towards the normal due to this reason. Fine. Okay. Moving to the second case over here. When light rays travel from denser medium, now the case is opposite, from denser medium to rarer medium. So as you can see over here, now it is from denser to rarer. So glass is denser and air is rarer. Okay. It bends away from normal. So as you can see, now this is the incident ray and this is the refracted ray. Are you getting it? This is the incident ray and this is the refracted ray. And this dotted line is a normal again. Fine. Glass is denser medium, air is rarer medium, and this is the incident ray, this is the refracted ray. Fine. Now you can see that when light rays travel from denser to rarer medium, it bends away from normal. Okay. And why away from normal? Because the speed of light ray gets increased in this situation. Okay. When the light ray is traveling from denser medium to, this is the denser medium to rarer medium, the speed of the light ray is actually increasing. That's why it is bending away from normal. Now, what will be the situation? Here, the angle of refraction will be greater than the angle of incidence, because it is now, you can see that this refracted ray is bending where? Bending away from normal. So away from normal, angle of refraction will be greater than angle of incidence in this situation. And why this is the case? Because the speed of light ray is increasing. Fine. Okay. Now moving to laws of refraction. So two laws are there. The first one, the incident ray, the refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. This is the first law of refraction. And the second law, the ratio of the sine of the angle of incidence, to the sine of angle of refraction is a constant. This is the second law of refraction. The ratio of the sine of angle of incidence to the sine of angle of refraction is a constant, or you can say constant value. Now basically this is called Snell's law of refraction. This second law of refraction is also called as Snell's law of refraction. Fine. Now sin I upon sin r equals to constant or constant value, and this is actually is the refractive index of the second medium with respect to the first medium. Basically, here the constant value, this constant value actually means it is the refractive index of the second medium with respect to first medium. Are you getting it? Now, let us now understand the concept of refractive index more in a detailed way. So, coming to refractive index. Now, what exactly the refractive index, what exactly it is? It is basically measure of bending of a light ray when passing from one medium to another. So, basically, refractive index measures what? Measures bending of a light ray when passing from one medium to another. So, it helps in measuring of the bending of light ray when it is passing from one medium to another. Basically, refractive index is for measurement purpose. Measurement of what? Bending of a light ray when passing from one medium to another. Clear? Now, how it is mathematically represented? Refractive index I have denoted over here as N. So, N is equals to C by V, where C refers to velocity of light in vacuum and V refers to velocity of light in medium. Fine? So, now this is the mathematical relation or representation for the refractive index over here. What can you conclude with this mathematical relation? What can you exactly conclude from this mathematical relation of the refractive index? That the refractive index is inversely proportional to V, and this V refers to velocity of light in medium. This is the conclusion which you can draw from this mathematical relationship, okay? Or with the help of this mathematical formula, you can actually conclude that the refractive index, okay, which is represented by N over here, is inversely proportional to velocity of light in medium. N is inversely proportional to 1 upon V. Okay. So there is an inverse relationship between refractive index and velocity of light in medium. Are you getting it? Now, you will understand this in a better way. Let's take an example. We know that here I have written Ri. Ri refers to refractive index. I have written in short form over here. Refractive index of water is 1.3 and the refractive index of glass is 1.5. So, if I'll take these two medium, water and glass, we can see that for if I take suppose glass, so glass is having refractive index 1.5, okay. So 1.5, which one is having high refractive index? See, these two, refractive index of water is 1.3 and refractive index of glass is 1.5. Now you tell me which one is greater, which one is having higher refractive index? Glass. Glass is having higher refractive index. So if the glass is having high refractive index, so what will be the velocity of light in this medium, that is in glass? High refractive index. So velocity of light, what will happen? Will decrease. Are you getting it? So velocity of light in glass will decrease as compared to that of water. Why? Because glass is having higher refractive index than water. So that's why velocity of light in water will be higher or faster, I can say. But in case of glass, it will slow down. Concept is clear. The velocity of light in glass will be slowed down. Why? Because the refractive index is higher. But in case of water, it will be faster. Why? Because the refractive index of water as compared to glass is lower. So now you must have understood that how the refractive index, which is inversely proportional to the velocity of light in medium is helpful by using this example which we have discussed over here right now. Okay. So in this way, you will be able to correlate the concept. So this refractive index is what? The refractive index, which is represented by n over here, is inversely proportional to the velocity of light in the medium, which is represented by v. Fine. I hope you all have understood the concept which we have discussed today, basically the refraction concept, and what exactly the refraction is, why are we studying it, and the cases, that how exactly the refraction happens. Fine. Then the laws of refraction, then the first law of refraction, the second law of refraction, which is also called as Snell's law of refraction. And you can see the formula, Snell's law of refraction, which is actually relating to the refractive index concept. Then we studied a little bit about the refractive index also, what exactly the refractive index is, the mathematical relationship over here. Okay. Then the conclusion which we can draw from this mathematical formula. Fine. And then we discussed one example over here in order to understand this particular relation. Okay. I hope you all have understood it. Thank you very much. Take care.